to move my window a little bit. Hopefully that'll do it for us. Okay, so in 32, based on the American Chemical Society, there is a 0.9 probability that in the United States a randomly selected dollar bill is tainted with traces of cocaine. Assume that 8 dollar bills are randomly selected. Okay, so our N is 8. Part A, find the probability that all of them have traces of cocaine. And then B, find probability exactly 7 of them have traces of cocaine. C, find the probability that the number of dollar bills with traces of cocaine is 7 or more. And D, if we randomly select 8 dollar bills, is 7 an unusually high number for those with traces of cocaine. So N is 8, P is 0.9. Okay, so in stat disk, we want the binomial probability distribution. I believe I saw it here. And okay, probability distributions. There we go. I thought it was under analysis and I kept not finding it. So it's under probability distributions. We want the binomial probability distribution. Now we're told we are selecting 8 bills. Probability of success is 0.9. Okay. And we evaluate. And I'm going to make this table a little bit bigger. Okay, so I may have to kind of slide my window as we go over this. So in part A, we're asked to find the probability that all of them have traces of cocaine. All right, on here we see our values for X, the probability of X. So for 8, it would be 0.430. Okay. For part B, find the probability that exactly 7 of them, so we look at 7, 0.38, and we'd round that up to a 3, 0.383. Part C, find the probability that the number of dollar bills with trace is 7 or more, so we want 7 or greater. Now, you'll notice some 2 other columns here, P of X, X or fewer, and over here, P of X or greater. So 7 or greater is going to be right there, 0.813. 0.813. All right, so if we randomly select 8 dollar bills, is 7 an unusually high number for those with traces of cocaine? So again, we want to look at X or greater. Okay, 7 or more, and we see the probability is pretty high, 0.813. So it's not unusual to get 7. 7 would not be an unusually high number. Okay, so we now have covered several methods for calculating binomial probabilities. We can use the table A1 in the back. We can use our formula, binomial probability formula. We can use the TI 83 or 84 plus, and we can use stat disk. So we have a large number of choices. Now I like stat disk for cases where I'm doing X or fewer, X or greater, simply because I'm lazy and it means I don't have to add them up or even subtract. So those are the cases when I like to use stat disk. In most other cases I'll use either the calculator or the table. Every once in a while I get in a position where I have to use the formula. So that's also useful in some cases.